Welcome. Welcome to a new episode of Embedded Journey. Last time we connect to the Wi-Fi AP and we managed to see the connection through our workflow. So today what we're going to do is we're going to build a TCP client. We're going to connect to the Wi-Fi, then we create a connection, then we send and receive data from the server. So let's jumping right to it. Okay, so last time we completed this code that connect us to the Wi-Fi access point. At this time, we are already connected to the access point. Now let's start to build our client connection. Of course, we need a socket. We're gonna need the type of connection, let's say the protocol. Third, we will need the type of security that this connection will have. If it will have a certificate or not, or both certificate or none of them. Third, we're gonna need the IP address for the server to connect. Then the remote port, as well as the local port. The local port is not that important because the module will select randomly a local port. So let's define our variable for the socket. In this case, we're going to use socket 0. We have the option to use from socket 0 to socket 3. So that will be 4 socket options. That's what the module is built on, okay? Then we will need the IP address. IP address is 4 bytes. So let's build an array of 4 bytes to hold the IP address. This is important because we need to specify directly which address we are going to be connected. We need to go to our command line or terminal and look for our IP configuration and see our PC IP configuration that is current. Also, we need to point out to specify our port. It's a 16-bit short word, because our port is going from 0 to 535. Sorry. So it's 16 bits. And that will be the port that the server will be listening to. Remember to download Hercules, okay? Hercules is a testing platform where we can test client servers, UDP, etc. Our remote port will be 5000. We will set up that. And then the IP address that I found is 192.168.1.105. This is my PC local address. After that, we need to start replacing the variables in our open client connection instruction. As I told you, the local port, it doesn't matter, set it to 0. So the protocol will be TCP protocol. Remember to specify that. Go to the header file, study everything so you will know. So you know every variable, everything. If you are not confident with that, go to the instruction and look for every variable that is indicated over there. That is required. So our TLS security mode, we're gonna set it up as TLS none. We are not going to have any security in our connection. Right now, it seems that we have our client connection set up properly. The only thing that is missing is the socket variable that we need to replace that with a correct variable name. So once we do that, we have everything in place to start our client connection. When the processor executes this, it would tell the module to connect to the server with these parameters. So everything is set up. Let's go to the next step. So once we are connected as a client, let's set up everything to send some data to the server, to tell the server that we are connected. Normally, the client sends some request and the server replies with an acknowledgement. We will simulate this with our little program. So what we will need in this connection to send data, we need to specify the socket, because the socket, remember, is the context that we built with the protocol, with the IP address, and with the port. The socket is the pointer to that context. After we set up this, we can start sending data. But first, let's evaluate the result of the client connection. Because if we have a bad connection, we cannot send any data to the server. And we need to send some message also to the server. And let's do this. Let's build a pointer to some string that we are going to send to the server. Also, you see the required length. The required length is the size of the buffer that you're gonna send. In this case, we're gonna do a string length to the data, so we can have it in the variable. Let's call it rlen. And the sent data length is the actual amount of bytes that were sent. So this is coming from our function. This is coming from the system. So if the required length is, let's say, 400, and the send data length is 324, then there is an error. So the required length at the end, the required length and the send data length should be the same, must be the same. Why? Because we are telling the system that we need to send 20 bytes, and we expect back that the sent amount of bytes is 20. Okay? So the amount of data need to be sent, and sent will be the actual amount of data sent. All right. So the timeout is going to be something reasonable, let's say 1 second or 2 seconds or half a second. You can test that and it will reflect your speed and performance of the library. In my case, I'm going to set 2 seconds. So after I send the data, we need also to evaluate the results. In the same way we're going to do with the open client connection. So if open client connection is not okay, then we're going to stop the program right over there. These enums are defined in the header files. You can go and look for it. Remember, the messaging system is inside the retarget library. I am using the msg.h definitions. You have another one that is log.h that have some other like details. I'm going to indicate some strings to be printed in the console to follow the flow. If you're going to have an error, I will print that the connection have an error. If we connect it to the server, let's say that we are connected to the server. If we are going to send data, at the beginning do this so you know the flow. It's very necessary to do that because we need to understand the flow of the connections. So this is the operational status. Remember, the rlen and the send after the send data operation need to be the same. It needs to be the same. And in this case, and rlen and send, they need to be equal. Remember, those two needs to be equal. So if they are different, there is an error. Those are the type of details that we need to know in order to have a proper handling of the flow and the configuration on our network connections. In the same way, we have to set that if there is an error, we set that error sending data or whatever string you want to put over there that you understand. One thing is, after the error, we don't need to continue to process the connection. We need to stop it. So one way to do that is putting after the printing the message error a while loop, right? It is necessary. If we connect it, okay, then we're gonna say that the connection is okay. So we send data, and after we send data, we put another message. So let's stop the processing after the error. Stay there in a while loop. Let's do the same with the error that we found, that we're gonna find in the send data. A while loop over there. It's a good practice. Right now, in some production configurations, it's gonna be necessary to handle those errors in a different way. Close a socket or whatever. Right now, we're gonna stop just for testing purpose. Now, we are going to receive some data from the server. Once again, the socket is the primary pointer for our context. Remember the socket. You cannot use socket 0 in the beginning and then socket 1. No, you have to use socket 0 all the way till the end of the connection. Let's reuse our buffer that we defined at the top when we started the Wi-Fi connection. Let's build it and configure it a little bit bigger so we don't miss any data. So we're going to use that buffer to receive data. We're going to tell the system that we're going to use the full size of our buffer to receive data. And the received data length is what we actually receive. It's a variable and going to be a pointer. Let's reuse also the one that we already have. So let's create another variable that would be holding the receive length. Okay, so we don't want to mix up the values, as those values are very important at the end. So it's a reference. We send it as a pointer, okay? And here we're going to wait 4 seconds. Let's wait 4 seconds for the server to respond to the client. Remember always to evaluate the result, the operational result of each function. In this one, we will evaluate if we got an error and also 0. Then we are going to print an error. Not necessarily receiving a 0 is an error. I'm just doing it right now for demonstration purposes, okay? Not always getting a 0 is bad. Sometimes the function times out and the result of the buffer is a 0 because we didn't receive any data. So make sure that you evaluate each situation very carefully, okay? If not, you're going to have an inconsistent client function. So we're going to receive data, and we're going to print that the data is received. I'm going to print the amount of data, the number, and the size of the buffer. So you will see the result when the program is running. Sometimes it is a good practice to do that. Let's reuse that variable so we don't send any fixed data inside the function. It is always also a good practice to do that. And you can send, fixed data too. It's not a problem. Then we're going to print the buffer, the content. Leave me in the comments what are the things that we are missing in that function. Leave that in the comment, okay? Let's review the block function, and to complete the flow, let's start the process with a printout to the console that we are opening the client. Remember, the very beginning is very good for you to do that because it will tell you in which step you are doing things the right way or the wrong way. So it's very good to do that. Check for errors. If everything is okay, then print out that you succeeded doing this, and before doing the other thing, print that you are starting the other process. Here, this is Hercules. You have to go to TCP server tab, set up the port, and start listening in that bottom. Okay, I told you, remember, look for the address. Look for the address. This is our address, okay? The client will be connecting to 192.168.1.105. This is our target address. Okay, so we have everything ready. Let's compile it. We still have a couple of warnings. Let's fix that. Maybe some data types that we need to fix. Those functions are expecting uint 8. Let's change it in the definition. It's better to do that. And then let's go and make the cast on each variable in each function. It's cleaner. Let's do it. Let's change that to Inventek 2. Okay, so because it is expected to be a chart, there we need to cast the string. Right. Then in the string length, I need to cast it to a chart pointer. See one warning. Let's see what it is. And the get module name. The buffer, because we redefine it as Inventek, it is expecting, I think expecting a chart. Yeah, a chart pointer. So let's cast it. Let's cast that to chart pointer. Very good. All right, no warnings. 100%. Okay. Very good. So now, let's download this program to our board. Okay, we have Hercules here. It's listening. We have the terminal, the console. Let's start the program. Let's see what's going on. Okay, initializing. Very good, connected. All right, waiting for the data, and then it closed. Tell me what's wrong there. Tell me in the comments. Why is doing this? Let's do it again. I send a response from the server, and you see it over there. Okay, tell me what to fix in order to avoid the first behavior. Tell me what to do. So now you see we connected to the Wi-Fi. We create a client. We send some data to our emulation server that is in Hercules, and then we send a response to the client, and we show that in the screen. This is the full flow. So what would you do different? What is this? Good. Working well. So we connected to the Wi-Fi. We connected a client to the server. Very good, guys. So this is the journey, man. We're going to see you in the next lesson where we create a TCP server. See you in the next lesson. Bye-bye.